Retrosphere is a self-contained passive 3D stylus tracker for lightweight augmented reality glasses. Our proposed solution provides low-power 6-stop tracking and a stylus that doesn't require any electronics or charging. Our aim is to enable spatial 3D interaction on portable devices with form factor and power constraints. On AR glasses, input is often limited to 1- or 2-dimensional on-device physical input, as hand tracking and other continuous camera-based tracking is impossible given the limited compute power. VR controllers, on the other hand, are not very portable for everyday AR use cases, and a smaller controller or stylus may need frequent recharging. Our solution is self-contained and can augment existing AR glasses for prototyping purposes or built into future products. Retrosphere consists of a pair of power-efficient stereo-infrared object trackers and co-located diffuse infrared LEDs that illuminate the retroreflective markers attached to the stylus. The entire 6-stop estimation pipeline can be run on device on a small controller such as ESP32. This allows low-power 6-stop tracking for continuous use, affordable hardware components, and easier integration into the AR glass form factor. The stylus has 3 retroreflective markers with different sizes for easier identification. Here we used 8, 5, and 10 mm diameter. Depending on whether we use 1, 2, or 3 markers, we support 3DoF, 5DoF, or 6DoF tracking. And this can be used with other controller form factors such as a wristband, stylus, or ring. As our 6DoF tracking algorithm processes very sparse data, this can easily run on a small microcontroller, which results in about 10 times power savings over existing 3D tracking approaches. At a distance of 100 cm, the average tracking error is under 2 cm positional and under 6 degrees rotational error, which is comparable to those commercially available depth sensors or controllers such as Kinect, Magic Leap, Intel RealSense, or Oculus Quest. Here we demonstrate how the stylus can be used in midair, for example, to draw 3D sculptures of a cube. Here we show how a user might interact with future AR user interfaces such as a button, slider, and list in 3D. We explored other form factors of Retrosphere. RetroPen, for example, uses 2 markers. A marker is attached to one end of a transparent acrylic cylinder, while a smaller marker is attached to a transparent acrylic rod inside the cylinder on the top end of the pen. A spring between the cylinder and rod allows the user to shorten the length of the pen with some pressure. This simple setup allows the tracker to detect contact of the pen with the surface and also makes this pen tilt and pressure sensitive. The differently sized markers also allow the user to flip the pen and use the end as an eraser. RetroRing is another Retrosphere form factor that we explored. An index finger ring and a thumb ring are used to roughly track the hand of the user. Each ring has a differently sized marker that allows the tracker to differentiate between the index finger and thumb. With a single retro ring on the index finger, the user can directly touch virtual user interfaces such as sliders and buttons. With both rings, we can detect pointing and pinching gestures for more elaborate interaction, such as drag and drop. We hope that Retrosphere will allow researchers and practitioners to study and prototype spatial input on lightweight AR glasses more easily.